Right, so Quick is a specification. Uh, it was initially kind of built or put forward by someone in Google. I guess it's just one person. And then it took off from there, and Google have their own Quick these days. It's called G-Quick. And Quick, adopted by the wider community, has been an IETF standard, and it's a living standard, so it's kind of not finalized, but it is formalized. So a lot of things have been specified over there, enough that people can start developing and implementing it, and that is what has happened. So that's what Quick. So Quinn is one of the implementations of the Quick specification. So Quick happens to be a protocol, right? So it's a protocol on top of UDP. Now people have problems with TCP because a lot of things sit in the kernel layer, and hence difficult to change, whereas UDP just gives you raw fire and forget kind of stuff, but it's not reliable. It doesn't have congestion control, so it was always intriguing. So people used to kind of put forward proposals for making it reliable and congestion controlled and all that stuff. So there was always things that are being built on top of UDP. Most notably, you might have heard of the microtorrent protocol, the BitTorrent ones. So that adds reliability and congestion control on top of UDP. Similarly, there is UDT, and we had experimented with all of them in the past, including UDT. Quick happens to be yet another one, but it's gained much wider acceptance in IETF standard, and that is what the future of the world is going to be. So with that, we code in Rust, of course, so we require something from the Rust ecosystem if it is possible, and only if it's not there, then we dip our hands into a C library and have some kind of a foreign function interface to bind to it. Fortunately for us, Quick had an implementation, two of them in Rust. One is socket agnostic from Cloudflare guys, and one is the one which is not socket agnostic by the Quinn guys, which is much easier and much modern to use, so we chose that. Right, so Crust is not really a protocol or something, right? It's an aggregation of stuff, so it's at the application layer. So Crust is whatever you can make out Crust to be. You can add stuff and make it more potent, or you can leave it where it is. So far, Crust, which stands for Connections in Rust, is contained only TCP, right? So it did contain UDP at various points, but predominantly TCP. And with TCP, as we know that we get very few things out of the box, and most of the things need to happen at the application layer. So secure serialization was some of our crates, which enabled encryption over the wire, so things could be detected if there's a man-in-the-middle attack and all that stuff, and a lot of other things. Quick, for instance, gives us all of these for free. So we moved away from a notion that we should make Crust multi-protocol and blah 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 to let's just have Quick because it solves all the problems, or seemingly it does. So we do not yet know whether it will solve once we put out in the wild, but we are confident by reading the theory and using it so far that it seems pretty solid. So you get congestion control, you get reliability, you get encryption. So Quick of course uses certificates in TLS, and there's encryption for free. You don't have to do anything at the application layer. You get multi-streaming, which is very important for us, because so far we used to have message queues in Crust to prevent something called head of the line blocking. So if you have a big message followed by a small message, the big message has to be delivered in entirety before the small message can get through, so which is called the head of the line blocking. So you're kind of blocking smaller messages because there's a bigger one in front. Quick, for instance, has multi-streaming, so you have a single physical connection kind of stuff and a lot of logical streams within them, and you can assign logical streams per message. So and they are all multiplexed, sort of interleaved in actual terms, and the receiver can then receive smaller messages quicker, and instead of waiting for the entire bigger message. So we used to simulate or emulate, I don't know what the correct term is, but we used to do that in TCP, and that included a lot of boilerplate. We don't have to do that in Quick. this is just one of them, right? So there are tons of these kind of things which you don't have to do with Quick if you use that, right? So there's the other advantage with Quick is the problem we faced with TCP in Alpha 2. So those are the things that we solved, right? Because you have the boilerplate and you solve those problems. The problem which we couldn't solve yet is the running out of socket descriptors limit. So if you have over hundreds and hundreds of connections, which is obviously important for the security that the overlay demands, bigger the section sizes, better the security and all that stuff. So and then you have neighbors, and then you have more connections and all that stuff. So once you run into hundreds and hundreds of connections, or even potentially thousands, you run out of socket descriptor limit, because on operating systems such as Linux, you have a fixed number that is set by default for the number of open file descriptors you can have, and socket descriptors are just file descriptors in Linux as well, so they're interchangeable. And we used to run out of them, and you couldn't create more sockets, and then you go into the problem of you can't have more connections. So you need fire operating system specific commands to kind of open that socket file descriptor limit to a bigger number. And that is because TCP is connection oriented. So the operating system kernel knows that this connection is only for this guy, right? So it's for 2 peers. So it allocates a new socket descriptor for it. UDP, on the other hand, is connectionless. So the operating system doesn't care. It will have a socket descriptor per socket, but that socket, it doesn't care who it is connected to. You can connect that socket to multiple people in logical terms. UDP really is not like connected. So Quick takes advantage of that, and what it does is like has a single UDP socket talking to many people and multiplexing all the information, because it does the multiplexing at the app layer, at the Quick layer. So the socket used is just one, so we don't run out of that socket descriptor limit. Right. So the good thing with this is, because Crust was multi-protocol, blah blah blah, we always needed to put in something more and something more and something more. With Quick, what we are imagining is this is it. Like, we don't require any more protocol engineering and all that stuff. So it brings everything to the table. And once you have Bootstrap and Bootstrap Cache and other things that we want at the routing layer, like external reachability and all that stuff coded, I don't think we might be looking at anything more from our networking layer, unless we run into problems with Quick, which time will tell. But hopefully, theoretically, we shouldn't, and so that's where we end.